All right, so go ahead and get logged into Big Ideas to the 2.5-2.7 practice quiz. And I'm going to give you guys extra credit for each correct answer that you have. So a half a point extra credit, so up to 5 points extra credit just for being here today, or at least if you're not able to join the Zoom live, at least watching the video. You have until 4 p.m. to upload your answers into Big Ideas, and that's just going to be extra credit. Your homework tonight is we have 2 IXLs, one today that we'll do for tonight's homework, and the one that we'll do for tomorrow's homework. Tonight's homework is an IXL. It's a geometry IXL, so you won't find it in the 8th grade section. You'll need to go to geometry and then go to S.11, and it's going to say similar area and perimeter of similar figures, which is basically what we did on Thursday last week. So it's going to review Thursday's lesson. You have to get to 80. Anything after 80 would be extra credit. Tomorrow's IXL is going to have us reviewing similar 3D shapes. So the surface area and volume of similar solids, like we did on Friday's lesson. And that will also be to 80, and anything after 80 is extra credit. So what we're doing, again, what we're doing right now is we are working on this particular practice quiz, and I'm giving you guys extra credit just for being here and doing it. Okay. Is Alex Aaron in our Zoom? Did he get logged in? I know he just sent me an email.
Yeah, I'm in.
Okay, excellent. Okay. So we'll go ahead and get started. I don't need a work paper for this. So literally you just type in your answers as we go through it on Big Ideas, you'll get the extra credit for it. Just so we know, and I think you guys know this, Mr. Sylvester probably said this as well, but starting tomorrow and then Wednesday, we are going to be following this schedule. Okay, so it's kind of a combo of a Wednesday starting at 8 o'clock, also a 2-hour delay schedule because all the classes are 30 minutes. And so there's going to be normal class periods. So can you guys see my screen? Can you guys see this? Okay. So period 1 will be 8 to 8:30. Then you get a 10-minute passing period. Period 2, 8:40 to 9:10, 10-minute passing period. Period 3, your extension, encore, band, choir classes will have Zooms. Period 4, same thing. Now, I did talk to Mr. Whirl. He said that you do not have to log into a Zoom during SLT. So that is just your study time. Okay, so you're only expected to log into your core and encore classes. SLT, you don't have to. You get an hour for lunch, plus your 30 minutes before that for SLT. And then 6th period, this is when I'll have you guys, 12:20 to 12:50 tomorrow and Wednesday. And then 7th period, we'll finish our day up at 1:30. Okay, Brady, what's your question?
So for the practice quiz, do we have to have a work paper for it?
No, you do not have to have a work paper for this practice quiz. Literally putting your answers in on Big Ideas as we go through it, and that's good enough. I'll do the work on my screen for you guys. What else was I going to say? I don't know if I was going to say anything else. So this is going to be a mandatory Zoom. It's like basically like a virtual day for Tuesday and Wednesday. So make sure your iPads are charged. I guess you're at home, so you can plug them in. Make sure, that's what I was going to say, make sure if you haven't done it today, that you use Mr. Horrell's attendance link to take your attendance for today. Tomorrow, I'll be taking it when we have class. So every teacher will be taking it in class. But for today, make sure you click on Mr. Horrell's link that he sent out. I also copied his link and put it in my Google Classroom post. Okay, let's get started. Practice quiz, this is 2.5 to 2.7. It says for number 1, select the parallelograms that are similar to parallelogram A. So we talked in section 2.5 about how similar shapes have the same shape but different sizes. And when I say same shape, I don't just mean that they're both parallelograms or both rectangles. I mean that their corresponding angles are congruent and their corresponding sides are proportional. You have to have the same angles, corresponding angles being the same, and their sides have to be proportional. So I'm looking for, I guess if you want to call it a length and a width, I'm looking for a length and width that would be consistent to a ratio of 4 to 2, which obviously we know is just 2/1, which means the length is going to be twice the width. So in rectangle B, or rectangle, parallelogram B, do we see that ratio of 2 to 1? Anybody? Well, this is awkward. Shane?
No.
No, you don't have to. Yeah, you guys don't have to raise your hand. Just shout it out. It's fine. I'm not. Yeah, I don't want 30 seconds of dead silence. Parallelogram C. Do we see the ratio of 2 to 1?
No.
No. Parallelogram D.
Yes.
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 Yeah.
Parallelogram E.
Yes.
Yes, also 2 to 1 because 2.5 is half of 5, so that ratio of 2 to 1 is still there. Okay, so parallelogram D and E. Moving on to number 2. Number 2 wants us to find X in these two similar rectangles, and so we can set up our proportion, and we can say that 10 on the blue rectangle corresponds to X on the purple rectangle. Going back to the blue rectangle, 14 is going to correspond to 7. Okay, it's not the only proportion you could set up, but it's a good habit to get into to be using the corresponding sides to set up your proportion. So when you cross multiply, you get 14x equals 70. And can someone tell me what X is going to be then?
5.
5
feet.
Yeah, I know you don't have to type it in on big ideas, but again, good habit to make sure we're labeling all of our answers, especially in this unit. So there's number 2. For those that are just joining, I am going to post this video after we're done. The 10 questions from this practice quiz are each worth half a point extra credit. So you'll want to make sure by 4 o'clock today, you input your answers in on big ideas to get the extra credit. Number 3, you multiply the dimensions of triangle A by 4 to create triangle B. Select the conclusions that you could make about these similar triangles. The ratio of the perimeters, triangle A to B, is 1/4. Well, if triangle A, we'll just say A, if I could draw an A, we'll just say all of its dimensions were originally 1, I guess you would say that. To go to triangle B's dimensions being times by 4. Everything's being times by 4. So because the perimeter ratio is equal to the side length ratio, then yes, from A to B, the perimeter of B would be 4 times what it is on A. So that is correct. It would be a ratio of 1/4 because maybe I should, this is kind of confusing. Maybe I should do this. A to B is 1/4 because they're timesing everything by 4 here. Okay. So for the second one, it says the ratio of the perimeters B to A backwards is 1/4. No, if I did it backwards and put B on top, it'd be 4 to 1. So that's not true. The ratio of the areas is 1 to 8. Well, if the side length ratio is 1/4, that means the perimeter ratio is 1/4. And what is that going to make the area ratio then? Anybody?
1 to 8.
Not 1/8.
1 to 16.
Yeah, it's going to square the side length ratio. So if the perimeter ratio is equal, the area ratio is the square of the side length ratio. So it's not going to be 1 to 8. It's going to be 1 to 16. Now, for the next one, it says from B to A. So if you go to A to B, it's 1/16. If you flip it around and go B to A, it would be 16/1. So that one's correct. And then it says there's not enough information. No, there is enough information because it says they are similar. So that allows these two ratios to come into play. All right, number 4. Draw the image of the triangle shown in the graph after a dilation with a scale factor of 2.5. Okay, so a scale factor of 2.5, if I was using arrow notation here, remember, would mean that all my coordinates are being multiplied by 2.5. So I put 2.5x comma 2.5y if I was using arrow notation to show my prime coordinates, right? Since we're just graphing that, I'm not going to make you guys do that here. But we have the point here 0, 4, And can someone tell me what 0, 4 would be if I times by 2.5? For the
0,
x,
10.
it would be 0, 10. That's right. Yeah. Because 4 times 2.5 is 10 and 0 times 2.5 is still 0. So there's our new coordinate for that point. Then over here, we have the point 4 comma negative 2. Can someone tell me what that new point is going to be if we times by 2.5?
And -5.
And -5.
And -5. That's correct. So that's going to be here. And then our last point is -2, 0. Can someone tell me what that's going to be if we times both by 2.5?
-5.
-5,
0.
0.
That's right. Okay, so we have our new dilated triangle. Now, again, I know it doesn't ask you about the, the box here, it says the dilation is, I'm going to guess that that's going to say an enlargement. I'm not really sure. So can someone confirm that? You guys, if you have it open, I'm digging.
Yeah.
That's what it says.
Yes,
It does.
Yeah.
Awesome. Okay. So if the side lengths are all being times by 2.5, that means the perimeter of this new image is also going to be 2.5 times bigger. And that means the area is going to be 2.5 squared times bigger, which actually, if I'm thinking, if I do it in my head, I think it's 6.25. So the area of this purple triangle would be 6.25 times bigger than the area of the gray one, just to again, keep using our perimeter. And the reason I want to come back to that is because that's tonight's homework. The IXL for tonight is going to have you do perimeter and area, similar figure ratios. Okay, moving on to number 5. Number 5, use the vertices. Okay, we have to graph it and then we have to dilate it by half. So we'll start by graphing. W is -2, 8. Yeah, you have to do both. I just read the instructions here. It says draw the figure and its image. So you're going to draw 2 rectangles here. X is 6, 8. Hopefully you're kind of doing this on your own. Y is 6, 6. And then Z is -2, 6. Makes sense. That's where it'd have to be to make a rectangle. Okay. And then we're going to dilate this by 1/2. So all the coordinates are going to get shrunk down. So that means that -2, 8 is going to go to -1, 4 for W. -1, 4 puts it right there. There's my W prime. And then it doesn't take a rocket scientist to find, to do Z, because if they're shrinking, if the image is being reduced by half, instead of having a side length of 2 here, it's going to have a side length of 1. So that means Z prime would be here, and you can tell that without even using the coordinates. Instead of having a side length of 1, 2, 3, 4, 5, 6, 7, 8, it's going to have a side length of 4. 1, 2, 3, 4. So that's where my new X prime would be. Let me confirm that. Should be 3, 4. And yep, we got it 3, 4. And that means this is going to be my Y prime. And so there's our new rectangle. And well, that's pretty obvious. This is going to be is it say reduction? What is the word that it uses there?
A reduction.
A reduction. Okay. Well, yeah. A reduction. Yeah. All right. So there's number 5. Moving on to number 6. Number 6, you dilate the rhombus with respect to the origin using a scale factor of 2, and then you reflect it along the image across the y-axis. What would the new figures be? So I'm going to use arrow notation for this because that's what we've been doing pretty consistently every time we have a problem like this. So I know A is 0, 0. That'll be an easy one. B is 1.52. C is 3, 0. And by the way, if you see me making a mistake, let me know, because I'm trying to do this in my head and trying to do it quickly for the sake of the video. So if we dilate by a scale factor of 2, that means, well, first of all, what would I write on my top arrow for that first transformation? Somebody.
Uh, 2x and 2y.
2x and 2y. Good. Okay. So then that's going to give us 0, 0. That's going to give us 3, 4. Kind of easier to work with that. 6, 0. And then 3, negative 4. And that's going to be after we dilate it. I'm going to move these down. Actually, I'm going to just move them up here. And then it says after that, we're reflecting it across the y-axis. Can someone tell me what happens when you reflect across the y-axis? Just shout it out. What happens to the coordinates?
X negative y. Oh wait, no, negative xy.
Negative xy. That's right. So there's no flipping. This isn't a rotation, but negative xy, because when you reflect an image, you take the opposite of the opposite coordinate. If you're reflecting over the y, you take the opposite of the x. For reflecting over the x, you take the opposite of the y. So that's going to be still 0, 0 here, because that point's on the line we're reflecting over. And then negative 3, 4. And then negative 6, 0. And then negative 3, negative 4. And just making sure this lines up. I did A, B, C, D. Yep, and it says A, B, C, D. So I want to make sure I had the right order. And so let's copy and paste that. Boom. 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 And there we go. Okay, moving on to number 7. If that was too fast for you, remember you can always go back and watch the recording and skip to this part. Number 7 says the red figure is similar to the blue figure. Create a sequence of transformations in which the blue figure would be the image of the red figure. So here's my thought. Obviously, we know this was dilated. That's a good good place to start. So here are our options. Could have been reflected over X or Y, translated, dilation by half or dilation by 2. If we're going from red to blue, was it reduced or enlarged?
Reduced.
Reduced, yeah. So we know that this is one of them. So because obviously if you times by a half, it's going to shrink. If you times by 2, it gets bigger. So I'm just going to go ahead and put that up there because we know that for sure happened. And so if we do that first, that means negative 0, negative 2 becomes 0, negative 1. And negative 2, 2 becomes negative 1, 1. And negative 2, 4 becomes negative 2, 2. Negative 1, 2, said that wrong. And 4, 4 becomes 2, 2. Okay, so this should be our new, yikes, let's use straight lines. Okay, that would be our new quadrilateral. What's another thing we know for sure has happened? I can't be honest. I'll be honest with you. I don't know what it was translated by yet. So we know it had to have been reflected. The question is, what axis would they have reflected it over?
The X.
The X
Yeah,
axis.
X.
Yeah, exactly. So if I flip it over the X axis, I'm going to do this in green. That's going to go here. One spot above goes one spot below goes one spot above. That's going to be here and here, and then right here. And so we're going to get this guy. Now we can tell, okay, so reflected over the x-axis. And then now we can tell how much it was translated by. It was translated right and then down. And so if I just need to track 1 point, how about this point right here? Right, 1, 2, 3, 4, down 1, 2. Right, 4, down 2 is this one right here. A translation of right 4 down 2, and I'll put that right there. So that was actually a sequence of 3 transformations. So that blue quadrilateral is a triple prime quadrilateral. Moving on to number 8. Number 8, you dilate a figure with respect to the origin using a scale factor of 4, and then you reflect it over the y-axis. Complete the coordinate notation, arrow notation, to show how the coordinates of the original image are related to the coordinates of the final image. Okay, so first of all, we see that it was multiplied by a scale factor of 4, and then we see it was reflected over the y-axis. So we're going to immediately know that scale factor of 4 gives us 4x and 4y. If I reflect it over the y-axis, which of those coordinates is going to be taken the opposite of?
X.
X. So if it was already negative, it'll flip the positive now. And if it was positive, it's going to go negative. So then that's going to be negative 4, negative 4x, and then 4y. And that would be both, that basically what essentially is happening in both those transformations if you did them in one. Number 9. The coordinate notation shows how the coordinates of a figure are related to the coordinates of its image after transformations, plural. Determine whether each sequence of transformations generates a similar or congruent figure. Okay, so we have 3 types of congruent transformations. If it was translated, if it was reflected, or if it was rotated, the image is going to be a congruent shape because we didn't affect the size at all. But if it was dilated, it will become similar. How will we know if it was dilated? By looking at the coordinate notation. How will we know by looking at the coordinate notation if it was dilated? What do you do to the coordinates if you dilate?
Multiply.
Yeah, if it was multiplied by something other than 1, right, which you wouldn't even need to write that. If it was multiplied by a fraction or a whole number or whatever, then it was dilated. If it was added, subtracted, flipped, taken the opposite of, so I guess timesing by -1 is still multiplying, but that doesn't change the size. If it was added times by -1 or flipped, the coordinates flipped, so it'd be a rotation, then it's still going to be congruent. So let's look here at the coordinates. Here we have, it looks like a translation of right 2, and then they took the opposite of the y coordinate, which means they would have reflected it over the x-axis. Neither of those are going to change the size of the shape. So this would be congruent. For the second one, top right here, I'm looking at, they multiplied the x and y by 2, and then they translated it left 1 and up 1. Now, translating it's not going to change the size, but multiplying by 2 means it was dilated at some point, and so that's going to be a similar transformation. What about the next one here? Can someone tell me what transformation happened right here?
90 degrees clockwise rotation.
That's right. Xander knows his stuff. I hope that the rest of you guys do too. That was a 90-degree clockwise rotation because they took the opposite of the x and then flipped it. And so that's not going to change the size. That's still congruent. And then the next one, this one obviously was dilated by a half. So it's similar. But can someone tell me what other transformation happened?
80-degree rotation.
That's right.
Or
Yeah.
100.
180. Yeah. 180-degree rotation would take the opposite of both coordinates and not flip them. So there was a 180-degree rotation and there was a dilation by half. So they reduced the shape, and that's why it's similar. Okay. And then number 10. The following list shows the different paper sizes. Now, your typical paper that you guys have when you grab a sheet of computer paper is called letter paper. It's 8.5 by 11. Okay, legal paper is slightly longer. It's 8.5 by 14. Then they have junior legal, which I don't even know what that is. That looks like a note card. The 5 by 8 is like a note card size. So 5 inches by 8 inches, and then tabloid, which is 11 by 17. Those big papers that Mr. Sylvester prints for you guys to do your map stuff on that you guys color. So it says, are any of the paper sizes similar? Well, there's one way to find out. Let's create a ratio of width over length and see if any of the ratios are equal for these shapes, for these rectangles. Obviously, they're all the same size. No, sorry, they're not all the same size. They're all the same shape as being a rectangle, but that doesn't mean they're similar. So 8.5 over 11 for letter. 8.5 over 14, obviously those two aren't going to be similar because the ratios can't be equal, but they could be equal to something else. Junior legal is 5 for the width, 8 for the length, and then tabloid is 11 by 17. And so an easy way to see if 4 ratios are equal is just divide them. You can see if 2 ratios are equal by cross multiplying, but to see if 4 ratios are equal, there'll be a lot of cross multiplying. It's easier just to turn them into decimals. So 8.5 divided by 11 is approximately, I'm going to round here, 0.773. Whereas 8.5 by 14 is 0.607. I'm using 3 decimal places because there's a lot of decimals here. 5/8 we should know is 0.625. Hopefully you know that one from last year using fractions. And then 11 divided by 17 is 0.647. So are any of the paper sizes similar? The answer should be no, they're not, because they all have different ratios. Apparently our bells are still on. That's awesome. That'll be annoying for the next 2 days. 2.5 days. It says part B, the dimensions of a government letter paper are each 1/2 inch less than the dimensions of letter paper. Is the government letter paper similar to anything? So now we have government letter paper. Government paper is 1/2 inch less than the dimensions of regular letter paper. That means it's going to be 8 by 10.5. Okay, so if we do 8 by 10.5, I'm getting 0.761. No, 0.762 if I round it properly. So then the answer would be no. Oh, I guess I didn't have to. Oh, I don't know. Is that drop down menu have it compared to any other paper or just the letter paper? Because if it's just having you compare it to the letter paper, the answer is obviously no, because you can't create a similar ratio by adding or subtracting. I assumed it was going to. So let me double check this real quick. I feel like it should have been similar to something. Let me double check this before we submit. So number 10 here. Oh, I misunderstood. Wait a second. Is your question different from mine? Does yours have a part C? Oh, no. Okay, never mind. It does. We're good so far. I did not. I'm glad I scrolled down. Okay, so part C. By increasing the shorter side of a legal paper by how many inches, it would be similar to junior legal paper. Okay, so legal paper is 8.5 by 14. Whereas junior legal paper is 5 by 8. So increasing the shorter side of the legal paper by what would it be similar? So here's what I'm going to do. The shorter side, when it says shorter side, that's the width. Let's get rid of the 8.5 and let's call it W for width. So let's find out what W would have to be for these to be proportional. And then once we find out what W is, we'll know how much we'd have to increase the shorter side of that legal paper by. Make sure I've got legal paper is the right one. Yeah, okay. So let's cross multiply. 8W, 14 times 5. is 70. And divide that by 8, and I get 8.75 inches. Okay, so that legal paper was originally 8.5. So if we increase it to 8.75, how much are we increasing the width by?
0.25.
0.25, yeah. So if we just increase it by a quarter of an inch, it would be similar to the legal paper. The junior legal and the legal would be similar. Okay, so there are your answers for this practice quiz. Go ahead and insert those, submit this. Hopefully it says 100%. If not, I guess let me know and I can unsubmit it for you. However, tonight's homework is the IXL. So don't forget about tonight's homework. It's geometry, not 8th grade, but geometry, S.11. You have to get to 80 or higher if you want extra credit on that IXL. It's a review of what we did Thursday. Tomorrow's IXL is a review of what we did Friday. So class time tomorrow, you guys still have to log in for 6th period. For class time, I'm going to let you guys work on it while you're on Zoom, and I'll just answer questions because I don't really have a lesson for you guys tomorrow, but you do have to log in still for the class in order to be counted present. Brady, you have a question.
Mine said I had 1.5 wrong.
Does it tell you which ones?
No, it just said 1.5 wrong.
Okay, well, I'm gonna go ahead and I'm gonna stop recording. Stay on the Zoom if you want me to tell you which problems it wants you to go back to. But if you have a 10 out of 10, you're dismissed. Just work on your IXL.